Yeah, the first part I think missed it. So I told you that filter methods, embedded methods, and wrapper methods. Filter methods always use it, so I have included in template. Embedded methods, I have used only random forest because out of all the algorithms that embedded methods has, RF is the best and it's more reliable. Even though in some case other methods give better accuracy, but rely on random forest. But the thing is that random forest embedded methods are not again suitable in all the cases. That is the reason I have mentioned true or false. So either true or false, try to check both. Whichever gives better accuracy, go with that. If at all there is any algorithm in as part of embedded methods, which is effective, that is random. And wrapper methods, don't use it. And of course, as I told you that once you gain a bit more and more experience, you will develop your own way of doing things, right? But I will explain all the methods. Okay, first one is filter methods. As I told you that filter methods are based on statistics. What does that mean? So let's get into one by one. Constant features, right? Constant features means, let's take that you have some input columns. Okay. Wherein all the values are, let's take 55. Some constant value, not to be just this 55. It can be any value. It can be string or it can be numbers or it can be float, whatever. As long as it's constant completely, we call it as constant features. These sort of columns will not add any value. What is the idea of model? Finding out the pattern, right? Pattern in the sense fluctuations, understanding fluctuations. This is constant. Do you think that it is anyway going to help the model to understand those fluctuations? Obviously, it's not, right? So that's the reason we avoid these features. Constant features, we call it as. Clear?
Yes.
Next one is quasi-constant. Quasi-constant means almost all the data is going to be constant, except very few cases, 1 or 2%. That is quasi-constant. Now the point is, how do we solve that? We have something, okay, the usual time test split and all, as usual. We use something called variance threshold, which is part of feature selection in scikit-learn. We have given 0.01. Any guesses why we have used point? I mean, this logic is for both constant, quasi-constant. Do you think that this can solve both constant, quasi-constant? The quasi-constant is slightly different, right? So here I have given 0.01, which means 1%. We can even give 0.02. But don't go, my suggestion is to stick to 0.01. So do you think that it is, I mean, we haven't written any logic for constant in that case. So will this work even for constant?
As 1% is like nearly negligible, maybe it works for both.
So basically this 1%, it can be less than or equal to 1%. So if it is less than or equal to 1%, means even 0% is less than or equal to 1%, isn't it? 0% means what? 100% constant.
100.
So the threshold is basically not a fixed one. It is in fact a variable one. So it's going to be like less than or equal to 1%. So this logic is going to work for both constant, quasi-constant. So once you create the object, going to fit it, and then you're going to get, we need to mention this object, whatever get support will give the number of, the columns that it consider as support. To say constant, quasi-constant. Let me give, I think here, yeah, I have given
In the
here.
data set, for which
Yeah.
columns are we applying that one?
Which data set?
I
Which
mean,
data
we
set
have
you are
taken the
looking
house price, right?
at? Okay.
Yeah, house price.
Yeah, it is going to
In
apply
that one,
for
the
all
constant
the
column, how to find?
how to
Should
no.
we
So
apply
all
Which
the
column it will apply?
what do you mean by which column it's going to
All
apply?
the column. Okay.
No, it's going to filter it out. So it's going to give us what all the columns that are not quasi-constant. Those columns we're going to keep it. And I change right here itself. So it's going to affect the extrain next test itself. So I'm changing the extrain. So it's going to filter automatically. This script is going to does that automatically.
So it will filter out constant or quasi-constant columns.
Right. Because I have mentioned only those columns, right? Columns. I have ignored the other columns. Because that is what this does. Clear?
Yes.
The next one is duplicate features. Duplicate features means, let's say that you have two or more than two columns which are having the same set of values. Suppose if I have column 1, then I have 22, 23, 24, 25, 26, 7, 28, 29. Okay, just I'm taking an example. And if I have another column, I have the same set of values. We can assume, right? So 23 and 23, 24, so on and so forth. Basically, when we have the same set of values in both the columns, we call it as duplicated features. Basically, we know how to remove duplicate rows, but we don't know how to remove duplicate features. We haven't discussed this concept. So duplicate features is basically having same set of values. In this case, we can get rid of one, isn't it? There's no value addition. In fact, it adds overhead. We need more CPU, RAM, and GPU memory, right?
Means two columns have similar, pattern of data.
Not similar pattern of data, same set of values.
Okay.
You can say this 20, 20, 23, 23, 24, 24, and so on. So,
More than one column should have same data.
right. The next one, okay. So how do we remove duplicate row features? I've written and I have taken an empty list wherein I can capture this list. Basically, we have used two for loops. Way it works is, let's take, I have column 1, column 2, column 3, column 4, column 5, column 6. Okay. I'm going to take another loop. So I'm going to get another one. What it does is the column 1, it's going to check column 1. To avoid the same column, what I did is, so for this is going to loop all the columns, right? In this one, I have mentioned I plus 1. So start from here in the next loop. This for first loop. And this is second loop. So even though we can mention from 0, but it doesn't make any sense, right? So I will explain why we have used I plus rather than using simply 1. 1 means it is going to start from here.
It will compare column itself. So
Right. So basically column 1 in the first loop, right, is going to check every combination of this, isn't it?
yeah,
Second loop,
column 2,
Column 2
3.
is
Column 3 it will start.
each
it
column.
starts from column 3. So it's not going to check other combinations. Why do you think that we are skipping column 1, isn't it?
Yeah, because it is
Already checked.
compared.
Because column 1 to column 2 or column 2 to
Already.
column 1 doesn't make any difference, right? So on and so forth. The column 3, next one is going to be column 3 and
From here
From
column.
4,
so next one is going to be column 4, right? So column 5, only one got remain, column 6. So it is going to check whether all the values are it's going to check, every value is equal or not. Okay, this so if it keeps on checking, like the column 2 comes from second loop, right? So that's now giving column 2. It's not actually second column, but this one. And the column 1 for the first one, it comes from yeah, here. Okay. So now it's going to check every value. If it is a duplicate value, it's going to list out here. So what we're going to get is duplicate features. So we need to get rid of it. So we need to drop from extend and extras. That's the reason I've given. But we need this in the form of list, right? When we want to drop multiple columns. So we already have it, and that's the reason I have given it in the list. Append it to list. Clear?
Yeah.
Yeah, of course, we need to, by default, it's going to check rows. So we need to make sure that it is 0. I have given in plus equal true, which means if we don't have this one, we need to reassign it back. So the reason I always prefer to reassign this rather than using these sort of things. Avoid this as much as you can, because when you execute something, first of all, you need to test it, isn't it? But in this case, it's fine, but you need to make sure that you test it. Suppose if you have code and you execute this one, you may lose, you can't, correct it back again. So in some case, what happens is when we have huge amount of data, you need to restart from again. So avoid these things as much as you can. Rather, even though it doesn't, we have a better option, always use this methodology. So most of the case, I try to avoid this in plus equal true. Hope you got the point why I avoid that, right?
It just replaces the data, right?
Yeah, we not to reassign it back. So we can use this, but this is a very dangerous one. So don't use that unless it's in this case, it's fine. Okay, so any questions on duplicated features? Stephen?
So the duplicate column is added to the duplicate feature variable, right? Column 2. If any duplicates are there, we will add it to the duplicate feature list.
Let's try and
Then we
drop
will delete that one, right?
it, yeah.
Yeah.
Stephen, any questions? Oh, Stephen is not part of this group, right? Okay, I'm sorry. The next one is correlation. Correlation, you might have heard this correlation previously, right? Heat map, CO or df.corr method, data frame dot core. This will give the complete list of correlation for every column combination, isn't it? We're going to give every column combination. We have seen this in pandas. The point is that if the columns are highly correlated, so if one increases and the other one also increases at the same rate or 90% increase. If I have one column, another column, it's of course data may be different. Data could be, let's take 1,000, whatever, right? So when we have data like this, if one increases and the correlation between these two tables, let's take the 0.99. What does that mean? That is positive 0.99, right? Which means if one increases, the other one increases at the same pace. Then if we have such columns, then it does not add any value to the model. I mean to say its model is all about pattern. When both are giving, going at the same rate, it's not, we are necessarily adding overhead. How do we find out that? Of course, we have core, which gives core, which gives the correlation for all the possible things, right? All possible columns. Now, where is it? Yeah, here. So we know how to get all the correlation numbers using core method. And what I have taken here is set, not list. The reason for that is it's going to check every combination, isn't it? So set, if I take set, the advantage is that it's not going to include duplicated values, isn't it?
Yeah, unique
So
value.
unique values. So that is the reason I have taken set. So where did I use that? Call core is it by itself. When we keep on adding it, there is a possibility that in this logic, it may have duplicated columns. So that's the reason I use set to avoid that duplicated values get added to this one. And so it's the same thing. So we're going to loop every column in 2 loops, so that we're going to check. Absolutely, you can see that. So where one increases, the other one is decreasing at the same pace. Again, it's not going to add any value to this one. Here I have taken threshold as 0.8, which is a good number, but you can even increase to 0.9 or 0.95. We don't want to lose columns, anything that is below that. It's your choice, but I prefer to have 0.8, and I feel that it doesn't add much value.
Is there a range for setting the threshold?
You can give any value you want, right? Like it's a 0.9. You can give it, right? Or strong in it.
Within one, like that?
What do you mean by within one?
I mean, you are giving like 0.1, 0.9 like that, right? So is it like 100% you are taking like that?
What is the suggestible maximum threshold value?
This is this is the maximum. This is the threshold that I suggest. It's your
Okay.
wish. You can change it to anything you want. Here I again use point. This is default value. Even if you don't mention it, it's going to work. But you can give any value you want. But I prefer in 0.8, 80%. And if it is anything greater than threshold, then it's going to capture. It's going to capture only the unique value, unique columns. So we have almost correlated 132 correlated features. I can drop those columns and get droppings. You can see that I think it's somewhere around 300 something columns. Started from where? Yeah, 369. From 369 to we got almost down to 116. So which drastically reduces the overhead, isn't it? Any questions?
Sir, one question that in the training set, uh, this will take from the x-axis, row wise. So then y-axis is equal to 1, it should be 0.
What is that?
In the train, when we dropping that 23.
Okay.
So we are dropping the row wise, right?
No,
Like
this
number.
is column wise. This one is column wise and 0 is row wise.
Yeah, 0 is row wise. But here we are drop the rows from X train.
These are columns, list of columns. This feature selection. Feature is nothing but columns.
Okay. Yeah.
All right. Okay, any questions on, I think we have completed filter methods. I told you that these methods are very essential and you always need to use it. That is my advice. And don't try to immediately jump to conclusion and feel that these are not necessary and these are necessary. Gain at least an year or 2 years experience of 1 or 2 years, and then you can keep judging others. Okay, keep judging other scripts. So for now, follow at least for a year, follow what I suggest, even in production. And then it is, of course, once you gain the experience, you know how to do things. Okay, so we'll move on to the next one. So any questions on this part? Clear?
Yeah.
Next one is embedded methods. Embedded methods are basically we are using algorithm to pick the most important features. We'll see how we can do that. Before even getting to this, I want to discuss wrapper methods first, and then I want to move to this one. Okay, because as anyway we're going to use it, but this one we are not going to use it. But let's discuss this one. So they have 3 options: step forward, step backward, exhaustive search. Let's take that you have bunch of columns. Okay, I'm not taking the data, just columns, list of columns. Of course, you have to take the data in real time, but I'm giving only the column names here. So just assume that you have data here. Okay. All right. So the point is, the step forward, what it does is going to take this column. Okay. It's going to generate model. It's going to apply algorithm, and it's going to generate the model only on this column. nothing else. All the other input columns will be ignored. One target, of course, it will have. It has to have. Okay, clear? So only one column is, so the model, first model is going to be only on one column. Second, it's going to go to another loop. And next time it's going to take only these two columns, column 1 and column 2. It's going to generate another model. Model 1 only on column 1. Model 2, let me write under this. Model 2 going to be column 1 and column 2. So every time it's going to check accuracy. Okay, accuracy 1, 2. So by adding this column, there's a possibility that it may either increase or decrease, isn't it? Or it can be even constant. Let's take here the accuracy is 67%. Okay. And here the accuracy is 58%. Do you think that column 2 is anyway going to be helpful?
Is impacting that column.
Columns. So in that case, column 1, it is going to stick. It's going to get rid of column 2. Okay. Is acceptable? Is not. Same way it's going to do for all the other columns. Model 3. So we have column 2 is not working. So okay. Column 1, column 3. Again, you will get some other accuracy. Let's take that this time it got to 72. What do you think that we need to do now? Do we need to include column 3 or column? We can go back, we can use only column 1.
We can include, I believe, accuracy increase.
Because we can, let's say, get rid of this column to completely. Okay. Now we need to include because the accuracy got improved from 67 to 72. Anyway, this one you can completely ignore it. You need to keep on doing it for all the columns.
Including column 1, we should include another columns and check whether the accuracy is increasing or not. That's it, right?
Yeah, you need to move forward, that's all.
But
There's
we
no
are
moving
doing
backward.
with the column 1 only, right? I mean, we are not generating a model for accuracy with the column 2 and 3.
And that is what I mean. So this is step forward.
Okay.
Step forward, this is how it works. So column 1 always be there. And step backwards is exactly opposite to that. When you have column, this is going to start from column 6. It's going to be column 6, column 5. Check the accuracy, whether to include or not. Again, let's consider that both are it got increased. Okay, 72. And again, column 6,
6 and 4.
5,
4.
4.
4.
That is, so it's going to keep on going backward. That's like the way we have step forward, but in reverse direction. That is step backwards. Got it?
Yeah.
The point that you brought in is exhaustive search. So if you have column 1 to column 6, so basically it's like column 1 only. Okay. Column 2 only. Column 3 only. Column 4 only. Column 5 only. Column 6 only. And then column 1, column 2. Column 1, column 3. Column 1, column 4.
4.
So it's going to check every combination of it. So if you have 6, what is 6 factorial? 6 into 5, 30.
34, 120, 123. Correct.
Yeah.
360,
5
360.
into 4 into 3 into 2 into 1.
240,
30, 120, 720, right? 120, 360, 720.
720, 720.
So 720 combinations. Just imagine how long it takes. Even the case of step forward and step backward is exhaustive. It takes a lot of time. Exhaust search is, of course, is going to kill the system. So don't use it, and these are not really effective enough. Filter methods are the best methods I always prefer. Even embed methods, you can completely avoid it. There's nothing wrong in it. Okay.
Yeah.
Unless it is extreme case where we can't, you know, uh, there is a, I mean, if we don't have any other options, let's say that we have very less number of resources, less amount of resources, then you have to go for it. But when it comes to implementation, it's not really difficult. I'll explain the core logic. The remaining part is loading data, splitting, and all. It's as usual. If we look at the step forward, that is that. You can see the only thing is we use ML extend library. Pip install ML extend. We may not have this library in your machine. Feature selection, sequential feature selector. So I've given alias SCFS. That's the reason I have given SFS. But you can directly use this one. Something wrong in it, right? Okay. So I'm providing an algorithm when we have it is going to take it can be any algorithm. For regression, we use some regression algorithm. For classification, we use some classification algorithm. What is important here is forward true. If it is false, that is step backward. It's the same logic. How many features that is going to select? It's going to select the most important 10 features. And it's going to check what? It's going to check the R2 score in the case of regression. If it is classification, we need to give the accuracy score. That is what this means. Right?
So that random forest regression method is inside SFS.
Yeah, inside SFS is going to use this algorithm to pick the most important. So we need model, right? We need model and accuracy. So we need model. So it requires some algorithm. It by itself has not going to have any algorithm.
So when we import the sequential feature selector, random forest will be there. So we will use that one.
I have used random forest because random forest is more reliable one compared to any other algorithm.
Okay. To import that one, when we import the sequential features, it will come inside that only, or for getting the random forest regression, it is different.
No, you are almost completed machine learning. I don't know for asking this sort of questions. We need to import it. Of course, we need to import. You can see that it's been imported random forest classifier. Classification we use random forest classifier.
Yeah, it's scikit-learn now.
So you guys are behaving like kids. Sorry to say that, but all right. So go back. All right. This one, after that, we need to fit it so that we can change the data set, right? All right. So anyway, we are not going to use this. Again, we have step backward also here. The same thing, except the forward equal to false. Okay, that is the only difference, nothing else. Any questions on that?
No.
Next one is exhaustive search. The only thing is the way I import this one, exhaustive search. Where did I imported that? EFS. Okay. Did I delete it? Check. Um, For some reason, the import has been deleted. I think the import has been deleted. Okay. What is that component called? Feature selection, right? Okay. EFS, I can write, I'll give you alias name as EFS. I think I missed this point. But if you execute in your machine, it will take a lot of time. You can give it a try. There's nothing wrong in it. Only thing is EFS. I can give you even minimum features, maximum features here. Minimum 1, maximum 4. So the scoring is based on R2 for regression, and for classification is going to be different. Yeah, ROC AUC I have used. Yesterday I explained, right, why we need to use ROC AUC. You can even use accuracy score if you want. ACC, that's all. All right. So any questions on wrapper methods? These are wrapper methods, these three. Clear?
Yeah.
Okay. The next one is embedded methods. Embedded methods, as I told you, that it make use of algorithms to filter out the important columns, right? It's not just one, there are many. One is univariate ROC AUC methodology, lasso algorithm, regression coefficients. Regression coefficients in the sense logistic regression is based on regression coefficient logic. So logistic regression and random forest, of course. Out of these, I have chosen random forest, embedded in the random forest. Even though these are the above methods, sometimes it works, sometimes it may not, it's not reliable. So this one I have chosen, random forest in this, okay? Again, this is not must. You have to try and find out. Try to avoid this as much as you can, embedded methods also. But filter methods are must. Clear? I'll explain how this works. For, of course, classification, I have given here univariate, lasso, regression coefficients. Okay, so this is basically on input columns, right? Doesn't matter whether it is classification or regression. I think here I given yeah, I think I given it here. Classification, in fact, it's for classification, right? Okay, the point is that I have not clearly given any segregation for regression classification. The reason why I haven't given a here is, when you apply classifier algorithms or regression algorithms, it's only on the input data. We are not considering the target columns. We are trying to filter out the important columns. So that is the reason I would have given a code classifier. I have not tested again regression algorithms, like distribution-free regression or whatever, but this is what I got. So ROC AUC anyway, in fact, it's classifier. So the point is we import the algorithm. I've taken base as decision tree classifier. So we can take any other classified problem algorithm, which can give ROC, AU ROC. I fitted it. The main point here is this is a base algorithm. Okay. If you go to this one, I've taken ROC AUC for every feature. You can see that we got predicted probability, right? Weighted probability in the sense is going to give us the probability for every combination, for every column. So that is the advantage here. So rather than going step forward, step backward, if we can able to get the probability, predicted probability for each column based, wherein we got this one from here. So we can pile up, let's take that in this case, the predicted probability on these columns are much better than this one, isn't it? So I can go only on this set of columns, which covers most of the area. Of course, there are too many columns here. You may need to expand it to much longer. But I hope you got the point. The whole idea is this one, predicted property on each column. It gives the list of predicted properties, and we need to, when we plot it, we're going to get this one. Of course, this I have given A or C greater than 0.5. Anything that is giving more than 0.5, only those columns been selected here. Okay. The same way, this is clear. This part. Next one is lasso. If you observe from here onwards, algorithms we directly use rather than ROC, ARC. We use something called select from model. Select from model comes from here, where it's part of cycling feature selection component. Whereas basically when we provide this to, I mean, when we provide some algorithm, it can be any algorithm. When we logic regression is not regression, in fact, it's a classified algorithm. So when we provide to this select from model, what it does is it is going to check the important feature. We can extract important features from this. Usually when we apply straight away with this one, it's going to generate the model. But when we provide to select from model, it will help us to select the most important features. Got it? So across all the embedded methods, you're going to see select from model. You can see select from model, logic regression with variation. So what we have used here is C1 penalty 2. We can try with the other hyperparameters also. I haven't discussed hyperparameters. We'll see that tomorrow. So logic regression C1000. Basically, it's the same algorithm with variation in hyperparameters. The same select from model. If you look at random forest also, it's actually same thing, select from model algorithm, right? So select from model will help us in picking when we provide algorithm to it, it's going to help us picking the most important columns. So we have applied all the methods, random forest, with the logic regression variation, C1000, penalty Ts, and logic regression with some other variation. And AUROC logic is going to be quite different from this one. So we applied how many? 4. We can try, no, there are a number of possibilities. These are the most important ones. Once we have this data sets, basically what I did here is for trying data set, I have created different data sets altogether for each of these. Extrain RF means for random forest. You can see extrain coefficient means for this one. Okay, logic regression 3000. You can see extrain lasso means this for this one. And AUROC I have created extrain univariate ROC. So the reason why I have created multiple data sets is we can evaluate it with, no, this one is without any embedded methods. Okay, this is with filter methods, constant, quasi-constant, duplicate features. This is filter methods again, correlated features. So original accuracy without removing any columns is 0.77. This one is 0.735, so which means it improved, right? Slight improvement. There's no much change. There's 77.232, 77.35. And correlated, after removing correlated, it is in fact even more increase, 77.96. And when we apply only on ROC AUC, 0.781, which means it got improved. And lasso is 0.790. So it keep on increasing. But these methods are not really reliable. That's what I can say. You can see that random forest is 0.80, isn't it? So in this case, filter methods with random forest will definitely improve. The accuracy is not, in fact, leave about accuracy. It definitely reduce the number of columns, isn't it? Without losing any accuracy. It definitely helps, right? We can reduce the overhead on the system. And of course, meanwhile, we're going to get an add-on thing here. We're getting better accuracy. From 77 to 80, 3% increase. Any questions?
No.
No.
I think this one, create a function to build logic regression. Okay. Okay, this is an alternative to decision tree classifiers. I have taken base one to in order to cross check this one. If you observe this, I have used a random forest, right? Random forest algorithm to cross check all the data sets, how much accuracy it's giving. The same way, I have taken another algorithm, loss regression. You can take any algorithm to cross check the accuracy, right? You can try all the algorithms, but it's not necessary. I've taken another algorithm for again our original data set, basic, correlated. Both correlated and basic comes under filter methods, and ROCUC in lasso, coefficients, and derivative models. So based on this, we are going to pick the. So do we need to add all this stuff? Not required. All the already the code has been created. You can select from model, right? Random forest. But this has been given as true or false. If this is false, this will not get executed. So the extend and next text is going to be the same thing. Okay. Any questions on feature selection?
So most of the time we will use the random forest itself, right?
Embedded. So that is what I said. Like not always recommended. Filter methods anyway, I have not given any option. You have to use. So
Yeah,
always recommend to use this. It's based on statistics, which are more reliable than any other method. But this one, you can always flip the value, true or false.
Yes, yeah.
All right. So that's it on feature selection. We'll continue tomorrow. We'll have session tomorrow too. We will, I think this part has been completed, this one. We need to discuss hyperparameters and ensemble algorithms. These
So
are
parameter tuning, hyperparameter tuning, that is the right topics.
right.
Oh.
Hyperparameter tuning and how this random forest gradient boosting algorithms works. I'm going to explain it tomorrow. So we'll conclude ML internals by tomorrow, and then we will start deep learning from Monday onwards. What is tomorrow? Yeah, Saturday. So we will definitely have session tomorrow. So please don't skip it. We will conclude ML internals. All the ML internals concepts are very essential, right? From interview perspective, and even in terms of implementation production. All right, that's it from my end. Have questions? Let me know. Or else, thank you. Thanks for joining.
Okay, no questions. Thank you.
Thank you, sir.
Thank you.